Okay, for this cycle that we have in the Aleks section 2.1, again looking at graphing parabolas. Now we have the given function y is equal to x squared plus 2x minus 2. And it says here to graph the parabola, plot the vertex and 4 additional points, 2 on each side of the vertex. Alright, and now we have for our given function, we have y is equal to f of x is equal to x squared plus 2x minus 2. And if I were to take what I have here, now this is in standard form, and if I were to convert what I have in vertex form, so again, I'm looking at separating the variable terms. So I have x squared plus 2x quantity minus 2. And if I look at the completion of the square, so again, leading term in the parentheses, okay, I have an x squared, which I want. So for completing the square, I'm going to take what is next to the first order x. That is number 2. And whatever coefficient I have, I'm going to take half and then square. Half of 2 is 1. 1 squared is equal to 1. And applying what I have here, so we have y is equal to x squared plus 2x. And I have plus 1. And to keep it level, now I'm adding 1 at the front. And to keep it all in balance, I'm going to take away 1. So I have here y is equal to x squared plus 2x plus 1. And that's going to be a perfect square trinomial. Negative 2 minus 1 is going to be negative 3. And for what I have in the case of the vertex form, x squared plus 2x plus 1, that is going to be the square of x plus 1, and we have minus 3. And we have, just with our components, we had the a is equal to 1. And for the value of h, this will be the 0 of the x plus 1, so I have h is equal to negative 1. And we have k is equal to negative 3. And since the leading coefficient is positive, okay, you're going to have the graph to open up from the vertex. And for our coordinates h and k, that would be negative 1, negative 3. And if I were to include additional points, so we have for y is equal to x squared plus 2x minus 2. Okay. All right. So again, whenever x is at negative 1, the k value is going to be the y. Again, so we had the vertex negative 1, negative 3. And if I move to the right and to the left, so whenever x is 0, we have y is going to be 0 plus 0 minus 2. And if I go one space to the left, this is going to be level. So I have negative 2, negative 2. And if I were to go, let's say, 2 spaces to the right and to the left of the vertex, so if I have that x is equal to 1, we have y is equal to 1 squared plus 2 times 1 minus 2. So we have 1 plus 2 is 3, minus 2 is going to be 1. So we have 1, 1, and 2 spaces to the left, and we have at negative 3. And you'll have the same y value. Here we have the square of negative 3, which is 9. And we have 2 times negative 3 is minus 6. So we have 9 minus 6 is going to be 3. Take away 2. So we have at 1. So we have negative 3, positive 1. So we have the vertex, and we have with our additional points. And if we apply to what we have in the graph, okay, so we got negative 1, negative 3, we have 0, negative 2, and negative 2, negative 2. Then we got 1, 1. Then we have negative 3, 1. Okay. Alright, so I had the vertex. Negative 1, negative 3, 0, negative 2, negative 2, negative 2, 1, 3, and made that, yeah. 1, 1, and negative 3, 1. So I got 5 points here. And connecting and checking. And the result is correct. Okay, now we have with this next function, okay, this one is already in vertex form. And we have y is equal to negative 2 times the square of the quantity of x plus 6, and we have minus 3. And we have a is equal to negative 2, h is equal to negative 6, k value is going to be at negative 3. And again, so you have graph is going to open down from the vertex. And the location we have at negative 6, negative 3. Now, upon taking what we have in this case, right, so we have with our x values, okay, so again we had x is h, which is negative 6, y is k, which is negative 3. So if I start out with the vertex, and if I just shift over one place to the left, one place to the right, so in this case I would just go one place over, and for what we have here, okay, at negative 5 and negative 7, since we have equidistant from x equals negative 6, we're going to have the same y value. So if I plug in negative 5 plus 6 is going to be 1. And for what I'm going to have in this particular case, right, so I have negative 2 times 1 take away 3, negative 2 minus 3 results as negative 5. And the same thing would result for negative 7. Okay, so we have negative 5, negative 5, and also would have negative 7, negative 5. And if I go 2 spaces over, so we have a negative 4 and negative 8. So we have with y, we have negative 2 times the square of negative 4 plus 6 minus 3. Negative 4 plus 6 is 2. 2 squared is going to be 4. Negative 2 times 4 is negative 8. Take away 3. So I have negative 11. So we have with further points, have negative 4, negative 11, and also have negative 8, negative 11. Alright, so in reverting to back to what we have in the graph, okay, so we have with our points, again, so I have, again, so I have negative 6, negative 3, and I have negative 7, negative 5, also negative 5, negative 5, and spreading it out, so I have negative 4, negative 11, and negative 8, negative 11, and connecting, and upon checking the result, And so that is correct. Quadratic function, we have y is equal to 2x squared minus 8x plus 13. And here we have this function is provided in standard form. And now, just taking what we have now, if I go from the standard to the vertex form, so if we look at separating the variable terms, they have 2x squared minus 8x quantity plus 13. And I want the first term in the parentheses to be x squared, so if I factor out 2, we have 2 times quantity of x squared minus 4x, followed by the addition of 13. And crossing over to the stage of completing the square, so you're taking the first order x term coefficient, have -4, again take half and square, and -4 halves is -2. Square of -2 comes out to 4. So we have here y is equal to 2 times the quantity of x squared minus 4x, and we have plus 4, plus 13. Now by adding 4, I'm not only adding 4, because since we have 2 factored out, I'm actually adding 2 times 4. So instead of creating a surplus at the front at 4, I'm doing it at 8. So to keep everything level, since I'm technically adding 8 at the front, I'm going to take away 8 at the end. So we have, in this case, I have y is equal to 2 times the quantity of x squared minus 4x plus 4. 13 minus 8 becomes 5. And in looking at what we have now for the vertex form, so I have 2 times the square of x minus 2. And we have plus 5, and we have so we have with a equal to 2, so the graph is going to open up from, and here we have h is equal to 2, k is equal to 5, so the graph is going to open up from 2, 5. And just lining up what we have now. Alright, so we had the vertex. Again, so we have it 2, 5. And if I were to shift over 1 unit to the right, 1 unit to the left, either way that you look at it, so if I plug in 1 for x, so you have 2 minus 8 is -6, plus 13 is going to be at 7. So you have 3, 7, and 1, 7. And if I shift over this time 1 unit further to the right as well as 1 unit further to the left. Okay, so we have with, say for x is equal to 0, we got 0 minus 0 plus 13. And if I had x equal to 4, I would have the same y value. So I'm going to have 4, 13, and 0, 13. And so just plotting these points, so again we'll have it 2, 5. Again I have it 1, 7, and 3, 7. I have 0, 13, and 4, 13. And putting together and checking the result. And the result is correct. Okay, continuing on with section 2.1. Okay, we have a function that is quadratic, and we're looking for what will be the minimum or maximum, and essentially what will be items that will stem from the coordinates of the vertex. Now, we have in standard form this given quadratic function, and to find out the minimum or the maximum, we want to translate this function in terms of its vertex form. So, starting out, if I separate the variable terms apart from the constant, so I have the quantity of negative 2x squared plus 16x, followed by the subtraction of 35. And in the parentheses, I want the first term to be x squared. So I'm going to go ahead and factor out the negative 2. Negative 2 into negative 2x squared is x squared. Negative 2 into 16x is going to be minus 8x. Again, we have followed by the subtraction of 35. And crossing over to what we have with the complete the square stage. Alright, so first term in the parentheses, we now have an x squared. And in the completion of the square process, if I take half of the coefficient next to the first order variable, okay, so I have negative 8 halves becomes negative 4. Negative 4 squared becomes 16. And now, for what we have with f of x, we're now going to have negative 2 times the quantity of x squared minus 8x. And in the parentheses, I'm going to add 16. And to keep everything in balance, okay, as I'm adding 16 within the parentheses, I'm actually, instead of adding 16, I'm going to be adding negative 2 times 16. And so we have at the front, we have negative 2 times 16 is going to be negative 32. And to keep things in balance, I'm going to offset the subtraction of 32 at the front by adding 32 at the end. And we have, in this case, right, we have with f of x, and we have f of x equal to negative 2. And for x squared minus 8x plus 16, okay, again, this will be a squared trinomial where we have the square of x minus 4. Negative 35 plus 32 is going to be negative 3. And we have with what's going to be the vertex, okay, your h value is going to be at 4, and the k value is going to be at negative 3. So we have, and we have with the coefficient a, which is going to be at negative 2, and because we have a negative sign, that means that the graph opens down from the vertex. And the vertex, which is hk, so we have the vertex 4, negative 3. Okay, because it's opening down from the vertex. Okay, a vertex can be the top point, so this would be the maximum location. All right, so for what we have in this case, all right, so does the function have a minimum or maximum value? In this case, it's going to have a maximum. And in terms of what the function's minimum or maximum value is going to be, that's going to be the y or the k coordinate. So that is going to end up at negative 3. And in terms of where the minimum or the maximum value occurs, well, the maximum is going to occur at x is equal to 4. And upon checking, and we have the correct result. Okay, for the fifth problem, okay, we have a vehicle factory which manufactures cars. The unit cost depends on the number of cars made. Okay, and we have C to represent the number of cars. Okay, so we have for the fifth problem, okay, we have a function C of x, okay, and C is equal to the cost. X is in reference to the number of cars. And we have the unit cost, C, okay, depends on the number of cars made. And we have X cars made. And if we have X number made, then the unit cost is given by, once again, this formula. And we're asking what the minimum unit cost is going to be. and it says to not round the answer. And now the minimum is going to be the vertex of this function. And if I rewrite what I have here, so this formula is in standard form, and if I separate the variable terms apart from the constant, okay, and what I want to do, okay, is that again I want the first term to be x squared, so I can move the 0.9 over, factoring out, and we have with 0.9 factored out, we have x squared, and negative 306 divided by 0.9, okay, so that's going to be at 340. So you have the quantity of x squared minus 340x. And we have plus 36,001. And crossing over to what we have with the completion of the square. So I'm going to take half of negative 340 and square half of negative 340 is negative 170, and squaring out, okay, so you had 28,900. So for what I'm going to have for c of x, I will have 0.9, and I have times quantity, so we have x squared minus 340x plus 28,900. I'm going to create a little bit of space here, and again we have plus 36,001, and now upon adding 28,900, what I'm actually adding instead is going to be 9/10 of that. So I have at the front, so we have 0.9 times 28,900, so we have 26,010. So I'm adding 26,010 at the front, and I'm going to take away the same amount. So, what I have for c of x, I will have 0.9 times the quantity of what is going to be x minus 170 squared, and we have 36,001, take away 26,010, so I'm looking at 9,991. So for what we have here, a is equal to 0.9, and we have for the h value, okay, that's going to be 170, and we have k is equal to 9991. So we have 170 cars, and the minimum cost, or per unit cost, okay, is going to be at $9,991. So in terms of, for lack of a better term, for optimizing, okay, for the minimum cost, this would be exactly at 170 cars manufactured, and the per unit cost we have at $9,991. And just going back and checking, so the unit cost, we have $99.91, and as I check, and we have the result to be correct.